Here we can see our digital oscilloscope, which is model number STS1022, which is 20 megahertz digital oscilloscope, two-channel oscilloscope. We are gonna perform frequency modulation and demodulation practical. Frequency modulation and demodulation of analog signal. So we can see, and we will explain further by performing lab. So further performing frequency modulation and demodulation, we have a SICO lab kit, which is a budget-friendly lab trainer kit for the communication engineering, which is built by Ambala Instrument. So here, first of all, let's check the sync signal of this kit. For this sync signal, we connect this connector cable to the channel 1 of the digital oscilloscope, and for the positive terminal of CRO, we connect this point, and for the ground, we connect whatever the ground you can use. Ground is commonly common ground, so you can use any ground of this circuit. So whenever you set or whenever you press auto set, there you can see pulse sync signal. By scaling it, you can magnify or make it smaller. So let's measure the voltage and the frequency of this signal. So here we can see 3.73 kilohertz of the frequency and voltage peak to peak 7.11 volt. So let's if we change the frequency, we can see that our frequency cycle is expanded. The less the frequency, the more cycle will be expanded. So here you can see. So let's check the AF signal output. Let's check it for the 2 kilohertz. It is given its lab manual. This trainer kit has built-in audio frequency generator of 2 kilohertz and 4 kilohertz, and built-in sine wave carrier frequency 60 to 70 kilohertz, 5 volt peak to peak approximately, and the phase in the demodulation section, the phase lock loop is used. So we can see here our AF signal. For this, we connected our AF signal output terminal to the positive terminal of the CRO, and the ground is commonly ground. So let's press auto set. So there is no signal. By the varying amplitude, you can gain the signal. So here I am slowly varying the amplitude, and the signal goes larger and larger. The amplitude is maximum. I have set the amplitude to the maximum, and the signal goes to the larger. So I can scale it by you can scaling by pressing this knob of the CRO. So let's measure the AF signal output. For this, we press the measure button and the show out button. So here we can see the 1.86 kilohertz of frequency, AF generated frequency, which is set to the 2 kilohertz maximum, and so it is maximum to the frequency of 1.86 kilohertz. So voltage peak to peak is 4.1 volt, and when I change the frequency to 4 kilohertz, it will change the frequency also. The frequency goes to the 3.72 kilohertz and voltage peak to peak is 4.453 volts. Now let's check the frequency modulation output section. For this, it has a built-in sine wave carrier frequency, which is we can see at this section, this part of the section, frequency modulated output. So whenever first I select frequency to the 2 kilohertz and press auto reset. So let's check the carrier signal as shown, as given in this lab manual of this particular trainer kit. It says 60 to 70 kilohertz built-in carrier wave. So for this I press again measure and show button. So here we can see 59.61 kilohertz of frequency carrier, which is carrier wave, and voltage peak to peak is 5.7 something volt. Amplitude to the minimum, and this peak point will node will work at demodulation section only, so you can ignore it in the modulation section. First of all, let's connect this AF signal output to the AF signal input. It use IC4UA471 for this AF signal input section, and at the next section it use BCO8038 IC, and at the last output of this IC is fed to the BC547 transistor. So let's complete our circuit. First of all, when the amplitude is minimum, the AF signal output will be, there will be no output of the AF signal, which is message signal in our circuit. There will be only output of the carrier signal, which can we see by the frequency modulation of the output. So let's complete our circuit again. In the channel 1, we will see the frequency modulation output, and the channel 2, we will see the frequency demodulated output. So for the first part, we connect the frequency modulation output to the frequency modulation input circuit. So for the second channel, to see demodulated output, we use second channel of the CR. We connect like this, and this is connected here. It is now showing only carrier signal of the modulated carrier signal only, which is 59.61 kilohertz is shown. When I slightly increase the amplitude button, it started to modulate it. It started to giving massive signal, so it started to do modulated. It started to modulation of the signal. So here we can see the frequency cycle is showing it's like a getting vibrated or something, because you have magnified it and showing it in large scale, so it is vibrating, something like a vibrating. For the next part, see the amplitude is when the amplitude is maximum, the modulating wave, we can see the frequency modulating wave. We can let's draw the signal first. Here we can see The amplitude or voltage section is taken here in this axis, and the frequency is taken in this axis. So suppose this is our message signal, at the, and this is our carrier signal. At the frequency modulation section, and the frequency modulation, what does actually frequency modulation does is, when the amplitude is maximum, the frequency cycle will be maximum. Here we can see this. We will see this by comparing the output later on. So now you can see this clearly. When the amplitude is minimum, the frequency cycle is the gap between frequency cycle is very huge, and when the amplitude is at maximum level, the frequency cycle is congested. At the demodulation section, we vary this knob P. So slightly when we started to vary, the demodulated output will started to come. When I slightly changing it, no. So now I can find my demodulated output from this point. We can compare this both signal. This is our output. At the output section, the channel 2 is connected to the demodulated frequency wave, which is shown in this blue color. I guess it is blue color, sky blue, whatever you like to say. And the input modulated wave is in this yellow color. When you scale it, you can clearly see that. When the amplitude is maximum, there is a maximum frequency, and when the frequency is varying, when the frequency is decreasing, the frequency cycle goes to the down. When this output section of frequency goes down, and the modulated wave we can see is here is a very gap. There is a gap in the modulated signal. So by this we can perform frequency modulation and demodulation.